Hi everyone, welcome to the video. Today we are going to solve minimum steps to destination. In this question you are given an integer d. This is the point at which you have to reach, okay? And you start from the zeroth value, index 0, and for every step, for every ith step, we can take I steps. Like for every ith move, we can take I steps. Suppose this integer as the final and last integer in our array, and we start from 0. Okay, suppose we have an array start from 0 to d, which is 0, 1 and 2. We have to start from 0th value. We can either move forward or backward, one step at a time, ith step at a time. Okay, now we have to return minimum number of steps required to reach this destination. Now when it will be possible, see example 2 will tell you a better picture. D was 10. Okay, D was 10. So how many steps you need to take? First you started from 0, you took one step. Then you can take next ith step, which is 2. Then 1 plus 2, 3. You have reached 3 till here. Then next ith step is 3. Then 3 plus 3, 6. You have reached. The next ith step is 4. Okay. Since we are iterating one step at a time, I plus 1, I plus 1. Okay. In that manner. So now fourth step. Earlier you already covered sixth step. Now you reached 6 plus 4, 10, and that is what you have to reach. So we will create two variables. Okay, we will create two variables. Let's say current and steps. Current and steps. Initially they will be 0 because initially we are at step 0, and currently you are at step 0, and initially you have took step 0 steps also. So while the basic condition, while this current is less than d, okay, this is when we need to do some operations. While the current position at which we are is less than d, okay, is less than d, or this current position, the difference between the current position and the end point at which we need to be is odd. Either it should be less than d, either our current position should be less than d, or the difference between current position and the final destination should be odd. Now why we are checking it? So let's say when this will be true, when the difference between current and final destination is odd, the loop will continue because we need to make sure we have to reach the target position, which is d. We have to reach at d with even number of steps. That's not reality, but we'll try. We need to try to reach d with an even number of steps, since jumps can only be of size 1 or 2. Like you can take one step, right? You can take one step, so you will have to make sure, you have to try the number of steps should be even. Okay, now in this case, now when both conditions are met, we'll append step 1 because we are taking I step at a time, starting from 0, then 1, 2, 3, 4, in that manner. Cool. And now that we have incremented the number of steps I plus 1, this number of step will get added to the current position. Let's say initially we are at n position, and now we have to add with I plus 1, so we'll reach n plus I plus 1 step. Cool. Now the moment any of this both of this condition break, or let's say any of the condition breaks, okay, we'll return the number of steps, because we have to return the number of value of I. Okay, as you can see, it does the job pretty effortlessly and in very less time. I hope you learned a new concept and enjoyed it. Thank you. Have a very nice day.